Hello dear students. Today we are going to see topic recurrence relationship. If you are given this kind of recurrence equation T of n, it is equal to T of n minus 1 plus 1 for n greater than 0, and the value of T of n, it is equal to 1 if the value of n, it is equal to 0. Now you will have one question, how this recurrence equation is formed. So to understand that particular thing, let me give you an example of one function test, in which I have passed argument integer n. If the value of n is greater than or equal to 0, if the value of n is greater than equal to greater than 0, we are printing the value of n, and this particular function is again calling this test function. The same function is there, it is recursively called, and that's why this particular relation is known as recurrence relationship. If we consider this particular printf statement is taking time 1, right, and this particular test function is recursively called n minus 1 time. That's why the total time taken will be, by that it will be t of n minus 1. So total time t of n will be equal to t of n minus 1 plus 1, and for if we are passing the value of n equal to 0, this particular portion is never going to execute. You see, this particular portion is never going to execute. That's why t of n will be a unit time, and it is equal to 1. Now what happens when we pass as an argument value 3? So if you are passing argument as 3, so what this particular function does, it prints the value and again recursively calling n minus 1. That's why test 2, again it is printing 2, and again test 1, again it is printing 1, and then it stops, right. So for that we are able to form this kind of recurrence equation, and as we know, there are three main techniques to solve any recurrence equation, and those techniques are: the very first technique is substitution method, second technique is recurrence relationship, or you can say recurrence tree method, and the third technique is master theorem. Today we are going to see the substitution method. So t of n value was given to us. Now what we have to do, we have to find out the value of t of n minus 1. So we will get t of n minus 2 plus 1. Same way, if we find out the value of we put this particular t of n minus 2 value here, we will get t of n, it is equal to t of n minus 3 plus 3. And as we know, we have to repeat this particular procedure how many times? K times. So in general, this is the equation we are going to get. T of n, it is equal to t of n minus k plus k. Now as we know, the value of, when the value of n is equal to 0, we know the value of t0, right. That's why for a basic step we have to assume that when this n minus k value will become 0, we will stop, and that's why we are considering that n minus k value is going to be equal to 0. If the value of n is minus k is equal to 0, we can write down straight away the mathematical equation, that is n, it is equal to k. Now if we put all these value in this equation, t of n, it is equal to t of n minus k plus k, we get t of n, it is equal to t of n minus n. Why? Because n, it is equal to k. So instead of k we can write down n here, right. That's why we are getting here t of n minus n and plus n. So t of n, it is equal to t of 0 plus n. So we get the value of t of n, it is equal to 1 plus n. Now which is the higher order term? Either 1 is a higher order term or n is a higher order term, and as we all know, right, n is a higher order term. That's why the time complexity of t of n, it is going to be order of n. Let us take one more example. T of n, it is equal to 2t n divided by 2 plus n if the value of n is greater than 0. and t of 1 it is equal to 1 if the value of n it is equal to 1. Let us try to solve this recurrence equation using substitution method. So to do so, what we are going to do, we have to find out first here. If you observe this particular recurrence equation properly, in a recurrence equation we are having t of n divided by 2 as a recurrence term. So what we have to do, first we have to find out the value of t of n divided by 2 and we have to put in this equation, that is t of n. So if we do so, t of n minus n divided by 2, we are going to get it is equal to 2t n divided by 4 plus n by 2. What simply we have done? We have just put n it is equal to n divided by 2. So instead of this particular n, we are getting we are putting n divided by 2. And if we put here instead of this particular n, n divided by 2, we get here t of n divided by 4. That's very simple. Now what we have to do? We have to just simply put the value of this t of n divided by 2 in this equation here, in this equation number 1, right? So we get t of n it is equal to 2 as it is we are writing. Now we are having n divided by 2, right? So if you put the value of t of n divided by 2, that is 2t n divided by 4 plus n by 2 plus n. So we get here 2 square t n by 4 plus n plus n. So we will get the value of t of n it is equal to 2 square t n divided by 4 plus 2n. Same way, again we are recursively getting here, you see, t of n divided by 4, t of n divided by 4. So what we have to do? We have to simply try to find out the value of t n divided by 4. And if we put instead of n divided by 4, we get this particular equation, that is t of n divided by 4 it is equal to 2t n divided by 8 plus n divided by 4. Nothing we have done, we have just simply put the value n divided by 4 instead of n, right? So again, now when we put the value of t of n divided by 4 in equation number 3, I hope you remember the equation number 3. Let me show you the equation number 3. So this was the equation that we people got, 2 square t n divided by 4 plus 2n, right? So if you put in that particular equation the value, we get t of n it is equal to 2 square t n divided by 4 plus 2n. So what basically we are trying to do, we are trying to make our generalized recurrence equation, right? So 2 square, again the value of t of n divided by 4, here we are putting, see here the simple, the whatever the value that we have got, plus this 2n we are writing as it is. So that gives us 2 cube t n divided by 8. So 2 square into 2, that gives us 2 cube plus n plus 2n. So in general, the equation we are going to get is 2 cube t n divided by 8 plus 3n, right? So now what is to be done next? Let us now try to understand the pattern of the recurrence equation, whatever we have tried to form, right? And from that, if you observe properly, the equation for t of n in general form you are going to get is t of n it is equal to 2 raised to k into t n divided by 2 raised to k plus kn. Now as we know in our base condition, right, we know the value of t of 1 and how many times this particular recurrence equation will be called. This particular recurrence equation will be formed how many times? How many times it is going to be called till that value becomes 1. So n divided by 2 raised to k equal to 1, it is our assumption. So it gives us n it is equal to 2 raised to k. Now simply if we take logarithmic operation on both the side, what we are going to get? K it is equal to log n. Now what we have to do? We have to put all these value into the general equation. Okay, so let me put the value in this general equation. Let me show you this general equation. Yes, this is our general equation. So what we are going to do? We are going to put the values in the general equation. T of n it is equal to 2 raised to k. Now as you see here, n it is equal to 2 raised to k, means we can put 2 raised to k it is equal to n. That's why I have put up n into t of n divided by 2 raised to k. This was our assumption, it is equal to 1 because this many times the recurrence equation will be called recursively. So t of 1 plus k value we have got here, that is log n, that's why this log n I have written, and this n value, let me show you that value one more time to you people. This n value, okay, this n value I am putting here as it is. So that gives us equation T of n, it is equal to n into T of 1 plus n log n. So now we know the value of T of 1, it is equal to 1. It is given in the base condition. So T of n, it is going to be equal to n plus n log n. And as out of these two, order of n and n log n, we know the n log n is the higher order term. That's why the time complexity of this recurrence equation will be T of n, it is equal to order of n log n. So in this video, we have covered substitution method. Master theorem also I have explained in one of the video, right? So all these are the techniques to solve the recurrence equation. I hope you will find this topic now easy, right? So try to solve few more examples and the assignment questions that I have already shared with you people.